So, hello, welcome to our tutorial session. Today we are going to talk about lists. Um, so, I'm sending WhatsApp messages now so that people can join. Okay, so today we are going to talk about lists. Okay, so from here, let's look at first. I'll talk about the zip function. It's a simple function you need to know about. Sometimes you may want to put things in pairs, like a normal zip. Okay, so let's go online and check something. So look at zip. Let me show you zip. I hope you all know zips, that kind of thing. So if you take this zip for example, yes, okay. So assume this side is one list. Okay, the left side is a list, and the right side is also another list. So what the zip does is that it puts them together, okay, in pairs. Okay, so you can see it's putting it together in pairs. So this concept is similar to Python zip function. I hope my background is not noisy. So if my background is noisy, please let me know so that I can. Is my background noisy? Okay. So please do all to like the videos for us. And so we are going to talk about the zip function. So let's say I have a first list. Let's say list one, 1, 2, 3, up to 4, and I have a second list, list 2, apples, banana, pear, and melon. When I say zip into bracket list 1, list 2, it will put list 1, list 2 together in pairs. So picks 1 and apple together, 2 and banana, 3 and pear, 4 and what? Melon. Okay. So that becomes a zip for us. So the next thing we are going to talk about is lists. Okay. So for Python lists, I don't need to demonstrate a zip. I'll do it later. So when you talk about a list, as I mentioned earlier, we've been talking about lists for so long, but today we are going to go into details. So for example, it says that Python list is like a way of putting a lot of data together. Okay, so you can have different data in a list. They can be of the same data type. They can be different data types. They can be, and there can also be a list in a list. Okay, so you can have a list in a list. That's nested list. So inside this list, you see that there's one list, and there's another list, and there's also another list. Okay, and all these lists are sub lists inside a bigger list here. Okay, so more so, um you can also have a list in a list in a list. You can go on and on and on and on. Okay, so a common way, this one you've been doing it so far, append. So it says what? X dot append 14. Okay, so that's list for you in general. Okay, so nested list, for example, if you want to represent this array or a matrix, you can put it in the form like each row would have one list of itself. So 2, 3, neg 1 is one row, 0, 9, 0 is another row, negative 11, 7, 13 is also another row, and all of them are in a matrix. So we can represent a matrix in a nested list form. But if you want to deal with a lot of math related stuff, go and watch video on learn NumPy. Yes, okay, learn NumPy for that. So now let's continue. So let's talk about list indexing. Okay, I mentioned earlier for strings, this first character is what? 0. It's in position 0. The index is 0. Okay. Then the next character is what? The index is 1. Then the next character, the index is 2, and so on and so forth. But for a list, we are not talking about characters, we are talking about elements. So inside this list, there are 4 elements. And the 4 elements, the first one is a string called love. The second one is a string is. The third one is a string kind. The fourth one is a number, 45. So this love word or string is in the index is 0. The index of is 1. The index of kind is 2. The index of 45 is 3. So just like strings, in this case for lists, we are looking at the positions of elements inside a list, not necessarily the sub characters or the number of characters in there. Okay, so if we take the list, you realize that this is in position 0, okay, and the is in position 1, the kind is in position 2, the 45 is in position 3. Similarly, when you are going in reverse, 45 is in position -1, kind is in position -2, S is in position -3, the lab is in the position what? -4. So the list, this one, you if you remember the lessons we learned on strings, it's kind of similar here, just that we are not counting the sub characters, but we are counting the number of items inside a list. Let me put it that way. Okay, so we call something list slicing, and just as you did for string slicing, it's similar to list slicing. But here in this case, the same way we use square brackets, only that when you talk about position 1, you are referring to the elements in the first position. Sorry. When you talk about position 0, you are referring to the elements in the first position. So 0 to 2, meaning that from first position to second position. So 0 and 1. Okay, so love is. Then when you say -1, then you are referring to what? The last one from the back. And the same way we reversed a string by using semicolon, semicolon, -1. Now the third position specifies the step, and the step can be what? +1 or -1. -1 means reverse, +1 means forward. And since you don't provide the start and the stop, it will by default start from the beginning and stop at the end. But since you are saying -1, then to reverse, it will start from the beginning and stop at the end, but reverse everything. So in that sense, you're able to reverse the list. So this is what you get. 45 kind is love. So 45 kind is love. That's what we get. Okay. Now we can also do some replacement. So if you say list and you provide the index 1, meaning that there's an item in position 1, which is, replace it with what? Is equal to R, meaning that replace the list which has is in position 1 with the word R. So your list will now change to something else. Okay. So let me do a quick demonstration on So first I'll start with the zip function. Okay. So the zip function, let us call the first list maybe list 1. Okay. And for my list 1, I have, let's say, numbers. Or let me just, I have A, small a, B, small b, and C. Okay. Then let's say my list 2. For my list 2, I have capital A, I have capital B, and I have capital C. Okay. Now, if I say, let me call it new list, or let me call it zipped list. Okay. Zipped list is equal to what? Zip function, I called it. Then you put in the I trouble. You need item 1, which is supposed to be an I trouble. Then you can put in as many as possible to zip all of them. Okay. So from here, we say, let me say list 2, list 1. Okay. It doesn't matter the order. So list 2, list 1 means pair them, put them together, zip them together. So when I run this code, Oh, I needed to print it out. So print zipped list. Okay. So when I run this, I get, okay, it's not allowing me to see. So it says that the object has been stored at this location in memory. At this location in memory. So let me say asterisk. Then we run it again. So we get capital A, small a, capital B, small b, capital C, small c. So the asterisk means unpack the data, remove the data, and show it to me. Okay. So this is what we get. It puts them together in a zip form. Okay. So that's all what you can learn about zips. Then let us look at the list. Okay, list as a data structure. So remember, when we say a data structure, we are referring to a structure, the structure of a data. Okay. So list usually has this structure. It's put in square brackets, and to have something like element 1, element 2, element 3, and so on and so forth. Okay. So element 1, 2, 3, and so on and so forth. And now it also has an index. Okay. So when you talk about the index is so you realize that element 1 is in position 0. Okay. The position of element 1 is 0. Okay. Then for element 2, the position is what? 1. Then for element 3, the position is what? 2. Okay. So this one has a position of 1. This one has an index of 2. This one has an index of 3. Sorry. This one has an index of 0. I always forget, as human as I am. This one has a position of 1. And this one has a position of what? 2. So go on and on and on. And that's how we did it for strings. So in here, let me create a list for LST, and let me call it, let's use what was in the slides. So love, comma, s, comma, kind. Kind 45. Okay. So we have a list of these 3 items. Now I can say that LST position 0. Okay. So I can print this one out. I can print this one out. So when I run this, let me comment this one out. Okay. So from the list, this is in position 0, if you can see. So when I change it to 1 and I rerun it, this is S. The S is in position 1. When I change it to position 2, I'll get kind. And when I change it to position 3, I will get 45. Okay, so these are the various indexes of the string or the elements in there. Okay, so someone is saying that the mic is low. I don't really know how to increase it. That's one big problem of mine. Okay, so um, here we are printing. So we've printed the positions. And as I said, when we say -1, it refers to the last element. Now remember that in our previous classes, when I was dealing with strings, I told you that when you are slicing, you put your object, let me just say object, okay? Your object, which could be a string object name, okay? Now there's a reason I'm calling it an object. So this is what I call object. It's a variable name though. So you can say object name or variable name, okay? But I'm calling it an object because this list is an object, okay? That's how Python sees it. Python sees it as an object. The first value you provide is what? Your start, semicolon. The next value you provide is your stop, semicolon. Then the last one is your what? Your step. Okay, so start, stop, step in terms of list slicing. So let us look at let me call it slice, or let me call it sliced. So when I put my object LST, I want to cut from position 0 to position 2. But remember, it will stop 1 less than 2. So this is 0, 1, 2. So it will give me 0 and 1. It will not end at 2. 2 will be excluded. Oh, I didn't print it out. So print slice. Okay. So it sliced the first 2 for me. Okay. We can say start at 1, stop at, let's say, 3. Okay. So this one will print starting at 1, S is in position 1, and 45 is in position 3, but it will stop 1 less than 45, which is kind. Okay. So this is how we slice. And sometimes you can specify the direction. So when you say 1, it means it should move from left to right. That's in the way we write. Okay, that's positive 1. But when I run this from the way we write, that's how it goes. But when you change it to negative, okay, now this one, when I change it to negative, then I have to start from the maximum. Okay, so here the step has to be positive. Okay, let me just put something in brackets here. Positive. Okay, so, or for, if the step is positive, then it means that this one will be, the starting value will be small, the stopping value will be big. But if the step is negative, the starting value should be big and the stopping value should be small. So you should start from the back and end in front. Then that's where you use a negative step. Okay. So for example, if I do this, if I put a negative but rather start from the front, I'm telling the computer to reverse from 1 and go to 3. Okay, but moving from 1 to 3 is not a reverse, it's forward. Going from 3 to 1, that's a reverse. So if you mess this one up and you run it, you get an empty slice. Okay, so it's empty because the computer started moving from 1 and going in reverse will never hit 3. Okay, so let us say put 1 here and reverse it to 3. I don't want to waste much time here. So when I run this, I get what? 3, 2, 1. It will stop one step before 1, and we get it in reverse. 45 and kind. Okay. So I know you should be able to slice because you've done it before with strings, slicing up strings and things like that. Then the next thing I want to talk about is um let's see. Yes, let's talk about the reversing. So with this list, I can reverse it. So I can say when you don't specify the stop, it will stop at the end. Okay. When you don't specify the start, it will start from the beginning. So when I run this, I'm going to get the whole thing reversed. Oh, okay. So 45 is kind. Just like semicolon, semicolon, -1 will reverse the whole string. Okay. Now let us do some replacement. So if you have a list, say LST, and let me say in position 0, you say it's equal to what? Let's say man, or let's say he. Okay, so it means that go to position 0 and replace whatever is there with he. So it will change this love to what? He. So once it is done, let us print the list and see. Print LST. Then let me comment this one out. So he is kind instead of love is kind. So you can use this method to replace certain strings in certain positions. Okay. So I think I've really dealt with some introductory part of this lesson. Okay, so now that we've seen how to manipulate lists, there are list methods. Okay, so let's go forward and learn about list methods. You see, when we're learning about strings, we knew something like dot upper, dot lower, dot capitalize, what dot what is it, dot reverse, dot count, dot, those kind of things. So list also has some of these things. Okay, so if we create a list, like for example, we say no, one of Bob Marley's song titles, no woman, no cry. Okay, so just say something. Um, let me just say 1998. I'm just putting something in there. Or let me make it a number. Okay, so we have this list. Okay, so we are going to look at what? List methods. List methods. And some of these list methods include, now to find out the list methods, you just type what? dir, then type list, meaning that find us all the list methods. Okay, let me run this and see if I'm going to get them. I have to print it out. Okay, so when you look down here, you find out that there are a lot of list methods. I told you that those with the double underscore front and back, they are inaccessible, or we don't use them. Okay, so we do not use them. So all these ones are inaccessible. From here upwards, we don't really need them because they all have what? A double underscore. So the remaining ones we can use, the list methods we can use are what? Append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. Okay, so I want somebody to type in the comments which one should I start with first. Which one do you want to know about? Which one should I start with? Somebody should type in the comments. Anybody? Sort. Okay, so sort is saying we should start with what? Retro mode is saying we should start with a sort. Okay, so let's start with sort. Okay, sort is the last one I mentioned. So when you talk about sort, the sort method, actually what it does is it sorts them out, it arranges them in order. Okay, so one thing about Python lists or data structures that you need to know is this. Now, for example, let me compare it with a string before we move on so that people don't get confused. So let's say I have a string s, okay, and the string is like let's say a, z, b, b, anything, something like this. Now, when I say a, or let me just say maybe new, is equal to s dot lower, let's say upper, okay, s dot upper. When I print s and I print new, notice that there are two different things. Okay, so I'm trying to make a point here. So you realize that s still remains as what? This, as the old string. Okay, s still remains as the old string. Now the upper method I applied to it only applies to this new one. So it takes this characters, convert them to an uppercase, and assigns it to a new one. So what the upper is doing is creating a copy. It makes a copy of this string it doesn't edit this one. It rather makes a copy of it and edits that copy and makes it an uppercase and assign it to a new variable called new, and we get this. Okay, so but for list it's quite different. So let us look at list. So let's say if I have a list and I have a number like 1 2 3, let's say 1 4, let's say 10 9 11. Okay, so I have a list like this. Now if I say let's say new list, okay, and I say l dot sort. Now sorting, you are sorting them in order, so it will start from what, smallest to the biggest. L dot sort. Now let's print L out first. From here, let me comment this one out. Okay, no, let me just undo that. So first, after creating the list, let me print the list out. Let's see what happens to the list. Then later, after printing it out, I would say what, sort. Then after sorting it out, let me print the same list out again. Then let me print the new list out, and let's see how the changes, the method we applied affected it. So you realize that for the string, as I mentioned earlier, the old one still remains old, but the new one gets the uppercase, okay, for strings. Now for the list, we created a list like this and we printed it out. Okay, so in this list, you will see that we've printed out the list and it is what, 1 4 10 9 11. Okay, then we said the computer should sort the list out and assign it to what, new. Okay, but then when we printed new out, which is the last one, it gives us none. So usually when you apply a Python method to a data structure, most of the data structures, especially, not all the time, but most of them, especially lists, as I know of, when you apply it, these new variables, it doesn't return an output. So these new variables you create, they become what, none. Their value is none. This process doesn't make a copy. Okay, this dot sort will go to this string, so I will go to this list. It won't make a copy, but it will rather rearrange it and assign it to the same L again. So realize that after the sort, okay, when we printed L out, after the first printing we made with the original list, when we made the dot sort and we printed the L out again, it has been sorted. You realize that 1 4 9 10 11, it has been sorted. Okay, and when we try to print the variable we're assigning to the sort, it says none. So when you're applying a sort method, you do not assign it to a variable. I repeat, do not assign it to a variable. Once you say dot sort, it will affect the original. Okay, it affects the original list. It changes it forever. Okay, so do not say assign it to a variable and all those things, just as you treat strings. Okay, so we say dot sort. So the sort method will what, arrange them in what, of in order. And remember, if they are letters, capital letters will come first. So from here we sort. Okay, now let me clear this one and make some more sorting. So let me delete that. Now let us sort this one. LST dot sort. Okay, we sort this one. Then we say print LST. So we print the list. Okay, here you don't assign it to a variable. Just do it, and the process will change this one itself. Then anytime we call this one to be a new version after we apply the method. So it says not supported. So type error. Okay, greater than, not supported between instances of int and strings. So it's confused between int and strings. Which one should come first? Let me remove the integer and let's do it. So if it's all string, it's all strings. If it's integers, it's all integers. Now who can tell me why the no came first? Because cry is C, right? C is a small C is from A, B, C is supposed to come before no or N. Why did no come before C? Anybody in the comments? Just a guess. Just a guess. Anybody making some wild guesses? Okay, so he's saying because N is capitalized. Yes, so that is true. And I think in earlier lessons I showed you the ASCII. Okay, American Standard for Information Interchange. Let us look at ASCII. I'm coming. Okay, so if you take a look at ASCII here, okay, you realize that capital A is the value is 97, the position. So in terms of ranking, wait, this is A, B, C, D. Which one is this? I think this one is supposed to be a small letter. This side is supposed to be small letters. I think this is faulty. I don't like this one. Let me. Okay, you let me just use this. Um. Okay, so from here we see that A is position what 81, all the way now small a is position what 113. So in terms of value, 81 is less than what 113. So when the computer is arranging them, capital A has a smaller value. So in terms of ascending order, capital A will come first. So you realize that Z will be down there. So Z will be position 96. Sorry, where is Z? Okay, there's Z 106. Then these ones come. Then A is 113. I don't think this is the correct ASCII, but at least it follows that order. That small letters have higher values than capital letters. But I don't think this is the ASCII format. Okay, Excel ASCII. Okay, so this is Excel ASCII. But I just want to illustrate that smaller alphabets are being represented as what numbers in terms of the computer memory. So smaller numbers, smaller alphabets, lowercase alphabets have higher numbers, and therefore they are seen what with higher values. So if you take a look, no, no on the other hand will have a smaller value than C. So C has a bigger value. But then here there's another no. So this C has a smaller value as compared to this small n. Okay, so that is how it's been arranged. Okay, so sort, if they are alphabets, it does it in alphabetical order. Now you can say sort order. So the key, you can specify reverse false. Okay, so you can say reverse is equal to true. Okay, by default the reverse is false. So when you say reverse is equal to true, then it means that what descending order. Okay, so run this, it will sort them and to put them in descending order, smallest one, biggest one first. Okay, so reverse is equal to true, then that means descending order. But by default, if you don't provide this, the reversing is what false, but you can still say false. Okay, and it will come out as the first one. Okay, so this is the sort method. Now let us look at another method. Another method we would like to look at is, okay, we started with a sort. Let's look at reverse. Okay, so sort and reverse. Now when we say reverse is true, what does it mean? How is it different from reverse? So realize that in reverse, in dot sort into bracket, reverse is equal to true. It arranges them in order and starts with the biggest one first. But when you say dot reverse, instead of sort, you say dot reverse. Okay, when you say dot reverse, it doesn't sort it, it only reverse it. Okay, dot reverse only reverse the list. So it starts with cry, no, woman, no. It doesn't sort it, which is quite different from this one. This one, it's arranged in order, but from biggest smallest. But this one, if you say dot reverse, it just turns the whole list upside down. The dot reverse is the same, is similar to the LST semicolon semicolon negative one we did. So it's similar to this, but dot reverse is more appropriate and better. Okay, so with a dot reverse, let me see if there are other methods, there are other things we can specify. Okay, so it doesn't take in any input and the output is none. So just say dot reverse and that's all. Okay, we've talked about functions and you should know how they work. Okay, so then from here we talk about dot append. I think most of you know how to use dot append. So dot append is used to add up what? Append adds up more to the list. Okay, so I can say append, let's say Bob, but you cannot put in more characters like this. You can only put in one at a time. Okay, and this append will add it to the end of the list. So when I run this, I get no woman, no cry, Bob. Okay, you cannot make more of them. Let's say Bob Marley. Let me just say you cannot duplicate them. Okay, so dot append takes exactly one argument. So we talked about arguments in yesterday's meeting, or no, 2 days ago. Some methods, you see, it's called method, but in reality, it's a function. Okay, it's a function associated to lists. Okay, it's a function that can be used on only lists, and that's why we call them methods. Methods are simply functions. They are specialized functions for a particular data structure. Okay, or they belong to a particular class. But functions like print, input, they are general functions. Okay, so this append is a method, but a method is a function. So if you look here, def append into brackets, blah blah blah. So it's also what? A method is simply a function associated to a particular data structure or a particular class. Okay, so in this case, the class is what? Class list. And dot append is, or append function is associated to that, the class called list. So it takes in only one argument. So if you want to add some more, you have to come to the next line and say lst.append. Remember, we are not assigning them to variables. We are not doing this. We are not doing x is equal to, no. We just do the dot append dot whatever it is. We are not assigning them to variables. So when I run this, we get no woman, no cry, Bob Marley. Okay, so append helps us to add up to the end of a list. It adds up here at the end of the list. Okay, so that's what append does. Then we can have extend. Okay, so sometimes, let's say you have two lists. Okay, let me just lst1. Let's say we have two lists. Okay, then this first list is saying 1 2 3 4. Okay, then we have another list lst2 saying what? 5 6 7 8. Okay, so these two lists 1 and 2 is we want to put them together, but most of you will be tempted to do this. lst1 dot append. Okay, and you say ls2. If you do this, it will add this list to the end of this part. to do this and put the list over there. Okay, when you run this, you realize that this is what I didn't print it out. So print lst1. Okay, so you realize that the whole list have been appended to the end of this set of strings, but that wasn't what we wanted. We wanted to append what is inside. Okay, so the obvious trick is, okay, let me run a for loop. Okay, instead of saying let me run a for loop, then I can say like for I in lst2. Okay, then I say append I. So the for loop picks up the data inside lst2 and adds it to I one after the other. And let me run this. Here's what we get. So it's continuous with that. But instead of using this for loop, we can use the control KC. We can use lst dot extend. Okay, so extend the list one, lst1 to this. So extended by lst2. So you realize that when we do this and we run it, we get the same effect. Instead of running a for loop, it unpacks the data in lst2 and adds it to lst1. Okay, but when we do append, we rather get the whole list being dumped inside another list, and that may not be what we want in certain instances. Okay, so I've also talked about extend, and let me say we have index, the index method. Now, index method tells you the position of a particular character. Okay, so if I take from here, let me cancel lst1. So from lst2, if I say lst2 dot index, now when you say index of 6, what is the position of 6? Now this one you will need to assign it to a variable. So let me call it pose. Okay, so I told you most of the methods are not to be assigned to variables. Okay, but for the index you have to assign it to a variable because the index is not going to change the list. The index function is not going to change the list. It's only going to what? Pick up the position. So you need to store it somewhere. Okay, so then later I will print, let me print position, pose. Okay, so when we run this, we get position what? 1. So to use the index function, you have to know the characters in there. I have to know that, okay, there's some number in there called 6. So you can use that. Okay, so we can say, and you can find so maybe index, let me try out something. So 6 comma 7, let's see if we can find this, but we can't find it because there's no list inside this list with 6 and 7. Okay, so it gives us an error. This value is not inside a list. So if you are looking for something inside a list, the reason why it's not because this itself are individual elements. Okay, if there was a square bracket here and another one here, then fine. Okay, so you can see that there is a list in there, and this one is going to tell us position 1, but initially there wasn't. So if you are trying to find something inside a list that does not exist, let's say so for example 9, and you run it, it gives you an error. 9 is not in the list. So anytime you use the index and the object doesn't exist, it just tells you error. Okay, so let us look at the next method called insert. So the insert method, you see, I told you about append. Append adds to the end of the list, but the insert adds to a specific position you want. So for example, if I say lst2 dot append, let's say 9, okay, it will add 9 to the end of the list. So when I print lst2, I get what? 9 added to the list, okay. But what if I wanted to insert 9 in the beginning? So that's where you use what? Insert. So you say insert, then you say maybe what position do you want to insert? So it says index. So which index? So index position 0, and what I want to insert is 9. Okay, so when I run this, to rather insert 9 in the beginning and it will update all the rest of them, their positions, I can insert it in position 1. Okay, so in position 1 means that 6 will shift backwards and 9 will be inserted in front of 6. So when I run it, that's what happens. 6 shifts backwards and 9 has been inserted in position of 6. So the index, you specify what? The position. So here you say that object, the list object dot insert square bracket, curly bracket, index, the position you want, then element. Okay, so that is how you deal with what? Insert. Okay, so then another method is copy. Okay, so this copy method is very important, very important. I know most of you will need it. So let us look at copy. Imagine you have this list too and you want to create a copy of it. So you say lst1. Okay, now in strings, let me compare it to strings because you guys are, so for a string capital S, and I have another string, say ijkl, or let me just say ijk. Okay, so that's a string ijk, and I have a small string. Okay, then I say s. Okay, now if I'm to print small s is going to be what? Small s is going to be a copy of what? The big S. So now small s is what? ijk. Now imagine I say new small s, and I say it's equal to the small s dot upper. Okay, for strings, we are dealing with strings. So then I put something like new small s. Okay, so I say that this small s is equal to the big S. So it means that this small s is a copy of what? The big S. Then I want to uppercase the small s and assign it to a new variable and print it out. Okay, so when I do that, you realize that all the variables turns out to be what? Capital letters. Okay, and here too, when I print capital S out, nothing has happened to it. You realize the small s has, the new small s has changed to what? Uppercase. The the capital S, which is the parent, okay, it still remains the same. But for list, it doesn't work like that. Okay, so for list, if I say lst1 and I say it's equal to lst2, okay, and later on I say lst1 dot append, let's say I want to add something to lst1. So I want two lists such that this is the old one, but I want to create a new list where I'll add something extra to it. So let's say append 9. So I'm expecting lst1 to be 5, 6, 7, 8, then add 9 to lst1. But lst2 should remain 5, 6, 9, 7. In this case, when you print out lst2, which is the original one, let me and print lst1. So let's say original. Okay, then let's say copy. Okay, so lst1 is a copy of lst2. Then after we made a copy, we added something to it. Now let us run it and see. Now realize that the original one also has 9 added to it. Okay, so in list, when you make a copy to a new list, whatever you do to that new list will affect the old one. It would affect the old one. It's not like a string. Okay, so whatever we do to this new list, when we say list1 dot append, we never did list2 dot append, but because list1 is a copy of list 2, whatever happens to list 1 will also change list 2. Okay, so what we have to do rather is, let me run this. What we have to do is to rather say dot copy. So we use a copy function to make a copy of it. When you make a copy, whatever you do to list 1 will no longer affect list 2. So when we run this, realize that original still remains 5, 6, 7, 8, but the copied one now remains what? 5, 6, 7, 8, 9. Okay, so without this dot copy, you can't really make a copy of it. If you just do a new variable is equal to the old one, hoping that it will copy, it won't. Whatever you do to the new variable will affect the old data. Okay, so you can use this copy to make a photocopy of it, then you use it. Any question? Any question? So any question? Any question in the comments? Okay, please do well to like the videos for me. At least we are using some effort here. So okay, so let us continue with our class. Okay, so we've learned about copy. Most of you are seeing a lot of things. Okay, a lot of things are just moving on here and there, and I'm teaching a lot at the same time. So let us look at pop. Pop is like remove, kind of, but it removes and gives you the character. Like you have a bag, and the bag is full of marbles, and you squeeze the bag, and it pops out one of the marbles. So you get what it has popped out, and you lose what has popped out from the list. Okay. So when I say and pop, you can assign a variable to it. So let me say num is equal to lst2 dot pop. So index position. So maybe pop the one in position 0. So pop means that remove that element in position 0 and give it to me. So after here, when I print lst2, the list, you realize that any number or anything in position 0 will be removed. And when I print num, this is what you get. So anything in position 0 will be removed and assigned to num. Okay. So when I run it, I get, you realize that the list has changed, and the one in position 0 has been removed, has been popped out and assigned to num. So I can use this pop to keep on removing them one after the other, keep on popping them out one after the other, and things like that. So that is it, pop. But do not use pop in a for loop. Okay, it's quite dangerous. It has a funny behavior when you use it in a for loop. For example, let me try using it in a for loop and let's see what happens. So let's say I have a for loop for I in lst2. Okay, so we have a list called lst2, and this lst2, we want to be removing the characters one after the other from it. Okay, and maybe perform some calculations and add it to the end or something. So when we say lst2 dot pop, so pop the one in position 0 for us. Okay, and maybe print it out. So remove it and print it out for us. Okay, we could have done print I. Okay, but I just want you to see how dangerous it can be using a pop. So when I run this, not all of the numbers will be printed out. Only 5 and 6 was printed out. Okay, now why? Because it makes sense. When I goes to pick the first character, in the first loop, I is 5, right? And or in the first loop, we had 5, and we popped out the one, like the 5. Okay, so when we pop out the 5, what will be remaining is what? 6, 7, 8. Okay, then in the second loop, we popped out again the one in position 0. Now 6 is the one in position 0. So then what we get is what? 6. So when we pop out 6, now what will be remaining is 7, 8. Okay, and in the third loop, we popped out the one in position 0, which is 7, and what's supposed to be remaining is 8. And now in the fourth loop, 8 is now in what? Position 0. And when you pop it out, it's supposed to be empty. So we are supposed to see, in this case, we are supposed to see 5 being printed out. Then in this case, you are supposed to see 6 being printed out. Then in this case, you are supposed to see 7 being printed out. Then in this case, you are supposed to see 8 being printed out, and the list gets empty. So that's the logic, but it doesn't work like that. The reason it doesn't work like that is, now I will go and pick, I would iterate over the loop, and there are 4 characters. So in the first loop, I is supposed to pick from position 0. Okay. Then after that, position 0 has been removed. This element here has been removed out of the list. Now the list is, what is remaining is what? 3 elements in the list. But I is what? 0. Now in the second loop, I is 1. I is now going to pick the element in position 1. Okay. And the element in position 1, it's supposed to be 7. The element in position 1, which is okay, which is 6. Okay, from this list, the element in position 1 is 6. Okay, then 6 has been removed. Okay, but after 2 loops, after the first 2 loops, now I is supposed to pick, is going on the third loop, but the list we have here is only 2. That means it's as if I want to pick from a position, like I is going to pick from a position less than the length of the loop. So it won't happen. Okay, so it won't happen. So do not use pop when you are using the same list. What I'm trying to say is that when you are iterating over a list, don't be popping the element out at the same time you are iterating over the list. You will get some funny behaviors. Okay, so if you want to remove, you can maybe create a copy of it and remove that one and be popping that one out instead of the original list or something like that. So pop removes an element from a list and gives it to you. But there's also another method called remove. I think so. Let me see, DRI list. So when we print it out, which one haven't I covered? So I've done append, I've done copy, I've not done count. So count, you know how to use count. I've done extend, I've done index, I've done insert, I've done pop. I haven't done remove, but I've done reverse and sort. So what is remaining is what? Clear and remove. Okay, clear and remove. I'll not do count. Count is so easy to be done. So from here, I would say, now when you say lst2 dot remove takes out the element but doesn't give it to you. Pop will delete the element but gives it to you. So let's say remove, but then for remove you have to specify the element you want to remove, not the position. So remove 8. Okay, so we want to remove 8. So when you run this, then we print out lst2. Okay, so when I run this, I get 8 has been removed. So the remove method or function associated with list removes, you have to know the character you want to remove. If you want to remove, let's say 6. Okay, now somebody is asking, so in this case it has removed 6. Okay, so let me see if there's a question in the list. So please, when you use the zip function, does the number of elements have to match in both lists? Okay, good. Thanks for that. I'll. Now, if the number of elements do not match, it will zip and it will zip till when the maximum length it can get. Then it will cut off the rest. Okay, so let me quickly demonstrate that. Let me say lst1, and we have let's say we have neg1 0 1 2 3 4. Okay, so this is 1 2 3 4 5 6. There are 6 elements and here there are 4 of them. Okay, so when I say, let me say x is equal to zip, okay, and I say lst1 comma lst2 and I print x, oh, so neg1 gets zipped with 5, 0 gets zipped with 6, 1 gets zipped with 7, 2 gets zipped with 8. Now 3 and 4 do not have partners, so they are being removed. It's just like a zip. It's like you're closing a zip and one end of the zip has terminated. You can't continue with the rest. The rest of them become useless. You can't continue with the rest. Okay, so it eliminates the rest of them. Okay. Okay, so please like the video for us and let me continue. So quickly, so far we've had about almost an hour now. So let us bring our coding session to a halt. So the last thing I was going to talk about was no, I was going to talk about clear. So when you say lst2.clear, it's deleted. So when we print lst2, it gets it deleted. Okay. So when I run this, it's deleted. Now the list is empty. Okay, so sometimes if you want to reset the list, you want to start afresh, it deletes the list. Okay, and if you want to create a new list, let's say a list called y, you can do something like this: lst. Now this is a new list, it's a fresh list. When I print y, it's going to be an empty list. So when I run this and I print y, that's just going to be an empty list. Okay, so you can use this to create a new list, or you can create another list this way. Let me say z. Okay, you can just put square brackets. So square bracket 2 would create another list that is what also empty. Okay, so you realize that both of them are empty lists. Okay, so that's how we can create what some empty list. So clear would delete everything from the list. Count, let me just do the count, then I know I've done everything. So count, let's count 5. The answer we are expecting is 1. So let me say, but count, you have to assign it to a variable. Let me say num, okay, because it's counting and it's supposed to return a value for you. Okay, so let us count 5. Okay, so there's only 1 5 in there, and we can say 5 again somewhere. Then we can, okay, so when we run this, we say that 5 appears twice inside. So count, you know how to use it already. So count is quite simple. Then okay, I'm done with all of them. So let me see. Clear, I've done it. Copy, count, extend, sort, reverse, remove, pop, insert, index, append. So this brings us to the end of our coding session. There are some few calculations here. Okay, tutor example. I'll send you videos on this. So write a computer program that would print out all prime numbers of the user's inputs in ascending order. So it gives the user will give us a list of them. Okay, let me quickly code this one, then we close. So let's say we are taking an input from a user. So first, let's say maybe let me call it data. Okay, let me say input. Okay, and say enter a string of numbers. Okay, So whatever the user will enter, separated by a space. So for example, looking at this example, we have 27, 12, 9, 19, 5. So you have 27 separate 12, 9, 19, 5. So it's going to come in as a string like this. Okay. So the next thing we have to do is what? We will say that what? Data is equal to what? Data dot new. Sorry, data dot split. Okay, so we are going to split this data into pieces. Okay, then let me try printing it out. So let me put this one here. Okay, so it has splitted them for us. Okay, but we need to work with them as integers. Okay, these ones look like strings. We need to work with them as integers. So what we are going to do is we are going to use the map function. So map, convert them to integers, and here's the split. Okay, so it will take each data from this list, convert them to an integer, and give it to us back. Then maybe we can still convert it back to a list from here. Okay, so now let me rerun this, and now we have it as a list. Okay, with our integers. Okay, remember prime numbers are integers, so you need them as integers, not floats. Okay, so we are to find the prime numbers. Now let me create a function up here. So a prime numbers function. Okay, so def, let me call it prime, then we put in the number. Okay, then it says for I, oh no, if num, let me say, for I in range from 2 to the number. Okay, if num divided by I will give us a remainder of 0, then return false. Okay, that means it's not a prime number, else no, else will not come here. So if it's done and never returns false, then it should rather return true. That means it tested everything and it was successful. So yes, so now that we have our data, let me comment this one out. Okay, so we have our data and we can run a for loop. So for I in our data, so if we put we call the function called prime and we put in I. Okay, now remember this I and this I are different. So I goes to pick a value from data. Okay, so let's say I goes to pick 27. Okay, so let me write data will look something like this: 27, 12, 9, 19, and 5. Okay, so I goes to pick 27 and sends it into the function called prime. Now if it goes through the function and it is a prime number, it will return true. So if true, if it returns true, that's if true, then we can create a new list. We can create a new list called new, and or maybe prime. Let's say prime numbers. Okay, so prime numbers should be an empty list like this, or we can just say list. Okay, so prime number should be an empty list. So if it is true that it's a prime number, we say prime numbers dot append that I because it's valid. Now once it is done doing it for all of them, we would what? Um, we would say that prime numbers dot sort, because once it's in what? Um, once it's in ascending order, okay. So dot sort, then I will print out prime numbers. Print prime numbers. Okay. So when we run this, you say Control V. Oh, there was something here. Okay, so we got what? 519. Where's 19 coming from? Okay, there's 19. So 5 and 19 are lists. Oh, okay, so let's see. So let me do my, now let me come in here. Maybe I think the problem is here. If the number divided by the factor is equal to 0, then it is false. Okay, so let me put on the for loop. Come here, run a debugger and run it. Okay, so from here, let me look at I. Okay, then let me look at prime numbers. So prime numbers is an empty list. I here goes to pick 27. Okay, so let me data. Okay, so I goes to pick 27, and let's see, prime I. So 27 is false. Okay, is 27 a prime number? No, it is false. So it goes back. I goes to pick the next value, 12. It's 12. So 12 is also false. Okay, so I goes to pick the next number, which is 9, and 9 is true. Okay, so 9 is also false. I goes to pick 19, and 19 is true. So to add it to this list, append. Okay, then I should go back to pick 5 and append. So we get 19 and 5. Then we get out of the loop. Then we sort. So yes, then it comes out as this. But I do not, oh, I put a square bracket here. That's why the double brackets are appearing. Okay, so when I run this, we get Control V. So I made a mistake here in the file. 27 is not a prime number. Yes, it's divisible by 3. Let me make a comment. So 27 is not a prime number. It is divisible by 3. Okay, so take note. Okay, so let me post it. Okay, so you have to take note of that. Okay, so given that, I think we are done with our class today. There are more projects. There's a second one, or okay, there's only one. So I'm going to send you your project, then you work on it. I think we've gone into some details on lists. Okay, so have a nice day. Bye. Please do well to like the video before you close. Do well to like the video before you close, before you leave. So yes, more reactions here and there.